Alright, let's talk briefly about creating a class. When you create a class, you must assign a name to the class and you must determine what data and methods will be part of the class. And so they give an example of the employee class as we move down the page. To begin, you create a class header with three parts: the optional access specifier, the keyword class, and any legal identifier you choose for the name of your class, starting with an uppercase letter as conventional. So that's how we name our class, like employee started with an uppercase letter. Public means public access, and we declared it as a class. The most liberal form of access is public. That means others can get to it and use it. The keyword public is a class modifier. There's a term you got to know. Classes that are public are accessible by all objects. Public classes can also be extended or used as a basis for another class. So what they're saying is, like, the employee class may be a well-structured, well-written class, but now they want to add some more ideas surrounding it. So maybe they add another class called salary employee or hourly employee, but its characteristics are inherited from the employee class, and just give a couple new concepts to an employee, a couple new attributes, and specific class information about salaried and hourly employees. You don't have to start from scratch. They didn't have to rebuild employee data, name, salary, address, phone number, stuff like that. They just relied on the employee class and added a couple more classes that are correlate to those records. Each new class can become an extension of the original employee class, inheriting its data and its methods. So any of the methods in the employee class can then be accessed from salaried employee and hourly employee, because there's common attributes and calculations that may be needed. So certain ones that need to be public. And there's more about that again in chapter 4 and the subsequent chapters. After writing the class header public class employee, you then have to add the body of the employee class between a set of curly braces. The body contains the data and the methods for the class. The data components of the class are referred to as data fields to help distinguish them from other variables. Now, they may look like variables, but they're slightly different. These data fields are variables you declare within a class, but outside of the method. So notice we've declared our class, defined our class, and we've created a private integer called employee number, and it doesn't belong to a method. So this is a public variable that's available to any of the subsequent methods that are part of the employee class. But because it's private, we cannot call it from an outside program and ask for employee number. We would have to do get num or get employee number. So we'd have to use a getter. So you have to kind of embrace that as I present you the structure of a finished class. You'll start to understand this a whole lot more. Each object gets its own copy of each non-static data field in its class. So as we make it, when we create a new employee, they each get a private empnum, an employee number variable, dedicated to their instance. So each employee is an instance, each one has its own employee number. That's pretty straightforward. So sometimes you assign private access to a field, and no other classes can access a field's value. Only methods of the same class are allowed to set, get, or otherwise use private variables. This takes us back to the principle of information hiding, and it's an important component of Java and object-oriented programs. A class's private data can be changed or manipulated only by the class's own methods, and not by methods that belong to other classes. So that's what I was saying. This private can only be modified within the employee class and its associated methods, like a setter or a getter. Well, a setter can change it potentially, but a getter is an accessor to get that data pulled back out. So we've kind of looked at the structure of the class now. These are some of the major concepts you need to know. You can take a look through the two truths and a lie on your own. I'm going to stop for now, then we'll move on to the next section. So next, let's look at creating instance methods in a class. Besides data, classes contain methods. We've looked at that already. One method you need for the employee class that contains an empnum is the method to retrieve or return any employee's employer number for use by another class. A reasonable name for this method is getEmpNum, and its declaration is public. Int getEmpNum, because it will have public access, return an integer, the employee number, and possess the identifier getEmpNum. So this one is going to be able to pass the employee number out of the method, so it needs to be public. Similarly, you need a method to set the employee number. Reasonable name for this method is setEmpNum. Its declaration is public void setEmpNum. Notice we got void in here, so we're not going to have a return, because it will have public access, return nothing, and possess the identifier setEmployee number. It requires a parameter that represents the employee number, which is a type int. So this one, when set up properly, is going to receive an integer to set the employee number, whereas this one sends the employee number out. Or this one brings it in and sets it as, it lets you be called by another method, whereas this one sets the value that a get would call. Methods that set or change fields are called mutator methods, and methods that retrieve values are accessor methods. So mutator methods are called setters, accessor methods are called getters. So mutate or modify or set, you're giving a value, you're setting a value is a good way to think about it, or you're modifying or mutating the value. Whatever makes the most sense for you, you gotta get the association between mutator methods and setters. And when you need to get some information, you need to use an accessor method. You need to access the data or get the data. So those two fit together pretty logically. And we will commonly use the set and the get three-letter prefixes. That is conventional. That is what you'll see on College Board. It's what you'll see throughout our class, and it is my expectation that you get used to writing sets and gets using the standard conventional methods of defining those particular constructors and accessors. All right. The get employee number and set employee numbers do not employ the static modifier. The keyword static is used for class-wide methods, not for methods that belong to objects. When you set up an employee, it becomes an object, and it has its own employee number. That's basically what they're telling you. If you're creating a class from which objects will be instantiated, most methods will probably be non-static, because you'll associate methods with individual objects, which is typically why we set up the classes. Now here's something you got to grasp. Non-static methods, or those methods used with object instantiations, are called instance methods. Alright, so a method, when the object is created or instantiated, it has a series of variables, attributes, and various other things that belong only to the instance of that name of that object. And that's kind of where they're leading us. Understanding when to declare fields and methods as static and non-static is a challenge. To help you determine whether a data field should be static, ask yourself how many times it occurs. If it occurs once per class, it's static. If it's once per object, it's not static. And so you need to take a sidebar and study this table after the video. You can enlarge it here. If I can, I'll paste it into the lesson today. And so we come down and they try to show you the difference between things that are declared public and private as part of this class, and then whether you can call them or instantiate them. So this is a valid instantiation. The object can use a public non-stan method there, but notice the bottom below, none of the following work. They're all trying to access either the class from the wrong order, or they're trying to access private data. So you need to spend a minute, see if you can noodle your way through that diagram so you understand that you just can do things two ways, but not every way. So these descriptions here will guide you through that. This class becomes a model for a new data type named employee that we've been working with. When employee objects are eventually created, each will have its employee number field, and each will have access to two methods. One that provides a value for employee number field, and the other one that retrieves the value stored there. Alright, so we have worked on an employee class and set it up. We have a private variable called employee number, and that doesn't belong to any of the other methods, so it belongs to all the methods. The first is our getter, where we return the employee number, and next is this setter that receives an argument or a parameter and sets the local variable to the parameter received. Remember, the local variable is always on the left, the parameter received is always on the right, and we went over a little bit of that in the last couple exercises. Alright, when you create a class such as employee, like you see above, you can compile it, but you cannot execute the class because it does not contain a main method. It is not a running program. It's an object and a class. A class such as employee is intended to be used as a data type for objects within other applications, as you'll see in the next section.